afternoon class. Previously, we have discussed about arrangement of resistors. We talked about parallel arrangement. We talked about the series arrangement. We have performed experiments. We discussed about experiments about arrangement of resistors in parallel. We discussed about the advantage of arranging resistors in parallel. We have talked about some advantage, and I remember I give you assignment about how to arrange resistors in parallel. So today we are going to see some examples of how arrangement of resistors in parallel. Our example says two resistors of 3 ohm and 6 ohm are connected in parallel across a PDF of 6 volts as shown below. We have a figure. This is the 6 volts, a battery connected to two resistors in parallel. We have 6 and 3. We have the current I is flowing, passing through, reaching a junction, let me call it junction A. And then, if the current I reaching junction A, it divides into two parts. So one comes as a current I1 passing through resistor 3 ohm. And then the current I2 passing through resistor 6 ohm. And then comes meeting at junction B to form the current I. Now, our problem number 1 says, how are I1 and I2 are related? Number B says, what is the potential difference across each resistor? Number C, find the value of I1 and I2. Then number D, the last one says, find the equivalent resistance of two resistors arranged in parallel. So, solution. Number 1 says, how are I1, I2, and I related? So here we have to start using a Kirchhoff's law. Let me say at junction A. Kirchhoff's law says that the current entering a junction, the sum of current in, let me say, the sum of current in a junction will be equal to the sum of current out junction. Now, at point A, the current I is entering a junction. So, current I is entering a junction must be equal to the sum of current leaving a junction. Must be equal to the I1 plus I2. So this is the answer of question number A. I equal to I1 plus I2. I1, I2, they are the sum of current leaving junction, while I is the current entering a junction. Then number B. Number B, we have what is the potential difference across each resistor? Now, let us imagine that this battery has negligible internal resistance. So, all potential difference occurring by the battery is across resistance. And we know that if two resistors are arranged in parallel, they have the same potential difference is crossing. They have the same potential difference. It means 60 volts is across each, let me say, each resistor. The 60 ohm volts is crossing each resistor because they are arranged in parallel, and we know that they have the same potential difference. And we have said, let us ignore the resistance of the battery, because in the problem problem, they didn't tell us that this battery is having internal resistance. We just say that it has negligible internal resistance. They share the common potential difference, which is 6 volts. So number C, find the value of the current I1 and I2. So we know that I will be equal to V divided by R. Now, can you say I1 will be equal to V divided by R1, while I2 will be equal to V divided by R2. So it means the I1 will be equal to 6 divided by 3, which is equal to 2 ampere. While I2 will be equal to 6 divided by 6, which is equal to 1 ampere. Then I will be equal to I1 plus I2, which is equal to 2 plus 1, which is equal to 3 ampere. Now, we have said number D says find the single equivalent resistor of these two resistors arranged in parallel. We have said that R, which is equivalent, will be equal to R1 times the R2 divided by R1 plus R2. So this will be equal to 3 times 6 divided by 3 plus 6, which is equal to, let me say, 18 divided by 9. So it is 2 ohms. So this is our example, and if you have any problem, you can ask on the comment. And any question you can have, you must ask it. Don't have any problem concerning physics while I'm your teacher. Thanks.